Welcome to the Teach Out. This is a Teach Out on hurricanes. And as part of this Teach Out, we started in 2017 talking about the large number of outbreaks of hurricanes that year, very destructive hurricanes. And this time we're going to add to it some new information where we've interviewed people who are experts in the field, who are actually in the field. We're in Puerto Rico, for example, and their experiences in the field and how that affected how their efforts are playing a role in helping people recover in those areas. We're also going to be talking some about new information about how climate change might be impacting hurricane strength, duration, and speed. And some new information about how experts are trying to quantify just how much could climate change actually be changing the strength and intensity of these hurricanes. Now, I teach a course here at the University of Michigan in extreme weather. And this course allows me to interact with the students and have them ask me questions that we can use as part of this exercise. So here's a question from one of my students.
It's a basic question. I never knew how hurricanes formed. So how did they form? How did it start off?
And that is a very basic question. So in part of this teach out, we'll start with that discussion. And one way to do that is to take a look at a hurricane. Here's a fantastic video from NASA of a hurricane in which we can see the characteristic features of a hurricane. The eye of the hurricane in the center here, we can see all the way down to the ocean surface. And around it is the eye wall. And you can see there's some strong storms. Now, if you stare at this long enough, there's many features going on here which are important to the formation of a hurricane. One of them, you can see sort of a spiral inside the eye itself, and that really represents something called hot towers. We're going to talk about what hot towers are and their role in the formation of the storm. But this storm is causing large cumulonimbus clouds rising up 10 miles or so into the atmosphere. And as that air rises up, it gets to the top of the troposphere, spreads out the top, and you can kind of see in here also the outflow going on in the hurricane. So at the surface, the air is flowing in a counterclockwise way into the center of the storm. At the top of the atmosphere, it's spiraling out in the opposite direction. So you have both going on, very characteristic of a strong hurricane. Now, the hurricanes are made from a process that's wholly different from what we have, say, in the Midwest. Here in Michigan, we have many storms, large precipitation events, and mostly those are called synoptic scale storms. And on that scale, they're produced by a different mechanism where the differences in temperatures between north and south produce gradients in temperature, which create gradients in pressure in the atmosphere. And those drive both the winds and also then drive other factors which are going to cause storms in the more temperate parts of the country. But hurricanes are an unusual beast in that they are formed entirely from the release of latent heat. That is, as water vapor is rising inside the storm, it's going to produce Hurricane Irma and Hurricane Jose in 2017. And we get some sense of the scale of these storms. They are obviously producing large amounts of precipitation. They're also producing very strong winds. Now, how do we get to a storm that's of that scale producing that level of precipitation? Here in a cross-section, you can see from NASA radar a picture of where precipitation is inside the hurricane. And it's not evenly distributed. It's very strongly there near the center of the storm. These hot towers, these strong thunderstorms here around the eye of the hurricane, then releasing great amounts of heat. Air is flowing from the surface into the clouds. Inside the clouds, they're condensing into liquid water. Water vapor going to liquid water goes through a process of condensation. The condensation is releasing heat at a rate of about 600 calories for every gram of water being condensed. And that release of heat means the inside of the cloud is actually going to be a little bit warmer than the air outside the cloud. Hence, you get convection. Hence, you get this upward motion inside the cloud. So it's going to carry the moisture from the surface higher into the atmosphere. And as it does that, it's going to produce a low pressure. It's basically removing mass from that column, throwing it to the top of the atmosphere, spreading out, producing a lower pressure, reducing the amount of mass in the center of the storm. If you get a change of pressure in the storm, so you now have what we call a pressure gradient from outside the storm to inside the storm, that's going to produce a stronger wind. We'll talk about all this in a moment. But that stronger wind means you're going to pick up a lot more moisture, waves splashing and such, more evaporation at the surface, more moisture is available, more moisture condensing produces yet a stronger hot tower, and more heat is released, and this storm is just driven entirely then by how much moisture is available in the atmosphere. And that's going to come back. We're going to talk about that, because if in fact the climate is warming, then potentially the surface of the ocean is going to be warmer and there'll be more potential evaporation from the ocean. There we have some concerns that it's going to lead to yet more convection in the future. Now, this particular storm is about 425 miles wide. It's about 10 miles high, so that's a large volume of air in which this condensation is occurring. And we're going to be measuring then the total energy that these storms develop. Now, energy inside the storm is going to be measured by how much wind speed it's creating. And the wind speed is by itself a good measure of how strong the storm is, but you have to remember the power of the wind. The power of the wind goes up as the cube of the wind speed. So if we have a wind speed, say 75 miles an hour, and in one storm, and a wind speed of 150 miles an hour in another storm, so you've doubled the wind speed, what you're doing there is increasing the power of the storm by a factor of 8, 2 times 2 times 2 in the process. So small changes in wind speed produce great changes in the power of the storm, and we're trying to quantify how much power each storm represents. Damage from storms comes from a number of processes. One is obviously wind speed, but the second is going to be precipitation. And as we'll talk about in a moment, how we classify storms at the moment has largely to do with wind speed, but we also understand that many of these storms now are producing huge amounts of precipitation, which also cause a great amount of damage, as we saw in 2017 in Hurricane Harvey in the Gulf states and in Texas in particular. And in Texas, some 50 inches of rain fell in 24 hours in some parts of Texas. That's an unbelievable amount of precipitation here in the Midwest. That's basically up to my neck in precipitation, or dropping a good portion of a swimming pool on the homes in that area. So that precipitation has to drain into the soil, and some of it can't drain fast enough, and we wind up with flooding. And then the wind itself is also going to move things around and cause great destruction. So as part of our teach out here, we're going to think about how wind speed and the precipitation play roles in the strong power and destructive capability of a hurricane. Now, hurricanes don't just happen. They go through stages. We're going to talk about the whole process of the evolution of a hurricane from its inception through a strong Category 5 hurricane. But to get to hurricane stage, we begin often with simply what we call a tropical cyclone. Often out over the ocean, these tropical cyclones are more or less just waves in the atmosphere, and these waves are causing areas of cloudiness. And again, as we go through this, we're going to discuss how those waves of cloudiness then begin to organize the clouds so that they kind of work in concert to release that latent heat. And once we've done that, now you sort of get a center of heat and a core around which the air can begin to circulate, taking us into a tropical disturbance, an early stage of a tropical cyclone. Tropical depression means now the storm is organized. That is, it has a center and is beginning to have rotation around the center. It's important, if you look at a map of where hurricanes occur, you're going to see that many hurricanes occur in the northern hemisphere and southern hemisphere, but none occur at or near the equator. And at the equator, they get plenty of thunderstorms, but they don't organize into rotating storms because there is no Coriolis force. So we're going to need also a Coriolis force to help these storms begin to rotate. And we'll talk about how that happens. You get to a tropical depression, your wind speeds inside the storm on the order of 39 miles an hour or less. You know, certainly a nasty storm, but not enough to cause great deals of damage. Tropical storms now are in the new range where it's rotating. It's not nice, the pattern we're going to see in the hurricane of a nice circular organization of clouds. It's going to be more sort of scattering of clouds. It's sort of a birthing stage, if you will, of the hurricane. And at that point, the wind speeds are going to be somewhere between 39 miles an hour and up to 74 miles an hour. Now, when you hit 74 miles an hour, you then cross the threshold, at which point we start calling it a hurricane. At 74 miles an hour, this is an entry-level hurricane. We measure hurricanes based on the Saffir-Simpson scale, scale of 1 to 5 in terms of intensity, but you can see on this slide that the intensity is entirely has to do with wind speed. Category 1 is somewhere around 75 miles an hour. Category 5 is around 150 miles an hour. So again, between Category 1 and Category 5, the power of the storm is going to be going up as a factor of 8, because of the wind speed cubed. Now in 2017, we've had a large number of storms, hurricanes happening, and in fact, 3 of the storms that happened in 2017 now are in the top 5 of most costly storms, hurricanes in history. So 2017 stands out as a particularly unique year in terms of hurricane destruction. And why is it? Why 2017? Why some years we get a lot of hurricanes? 2005 we got a lot of hurricanes. 2017 we got a lot of hurricanes. Other years none or very few. So what happens? Why are some years different than others? We're going to talk at the details of why there's such variation from year to year. If you're in a location though and you hear either of these two words, you must take note. Hurricane watch means that the conditions are right. The storm is out there over the ocean. The storm is going to come on shore, and there's a probability that storm is going to come into your area. So this is a point at which you want to start making plans for what will you do. How do you board up the windows? Is there some way, some place you can go, like back to Michigan, to where we don't get any storms like this? Is it possible for you to leave if you're in Puerto Rico? What would you do when a hurricane watch happens? What are your options is important to think about. A hurricane warning means the storm is imminent and the probability of it hitting your town is extremely large. So at that point you should have taken the action you need to get, either if you can, to remove yourself from that area if you're near the water. Because one of the big concerns is going to be storm surge, where the ocean itself is brought on shore and the flooding is going to cause the damage in your area. If you can get to high ground, maybe that's safer. Think about, listen to the people who are for FEMA or whoever gives you the advice about what you might do next to protect yourself. But this is a serious situation when hurricane warning is occurring in your area. Let's walk through each of these 5 categories of hurricane. We have some data from the National Weather Service showing us that each of these hurricane has its own strength. Hurricane Category 1, 74 miles an hour is the entry fee into hurricane status. At that point, these are storms which are serious, but they're not going to cause maybe as much damage as some of the bigger storms here. Primary damage to unanchored mobile homes, shrubbery and trees, there will be damage, but it's not generally going to be as life-threatening. That said, every year in my class I choose a student, and we take this student and stick them in the wind tunnel here at the University of Michigan and turn it up to hurricane force to about 75 miles an hour and film the student standing inside their thing. Now the student, please understand, is roped in, still a tad unnerving because it's, you're inside a dark chamber and there's high winds and there's some fans somewhere behind you. You don't want to fall down into the wind tunnel. But even standing there, it's really hard to stand up. Even though you're roped in, it's really hard to stand up at 75 mile an hour winds. And if you turn your face sideways through the Bernoulli effect, the air is kind of blowing past your mouth. It makes it really hard even to breathe at 75. So an entry-level hurricane is still a significant windstorm and is to be taken quite seriously. Category 2 hurricanes, now we're getting the issue of storm surge. We're going to talk about storm surge. This is the water being blown on land by the winds coming on shore. And you've got both the wind speeds blowing the air on shore. We got the lower pressure inside the hurricane causing the water level to be a little bit higher to begin with. And on top of that, if it comes on shore at high tide, you've got the addition of the effect of the moon then on how much storm surge is going to happen in your area. This can cause a great deal of damage. And remember, on top of the wind speeds, though, is going to be how much precipitation. Are these storms moving slowly? If they're moving slowly, you might be under the precipitation bands for a long time. And that, in fact, we'll talk about later, is one of our concerns for the future. It's possible that as climate warms, these storms may not be more of them, but they might move slower and they might have more energy in them, so which could lead to far more precipitation. We'll talk about why. Category 3 hurricanes now to up to 130 miles an hour. Low-lying escape routes or might be cut off because of flooding, either the precipitation or if not the storm surge. Category 3 again is a time where you probably don't want to be in your home if you're anywhere near the coastline. Category 4, we're up to 155 miles an hour at this point. There's going to be failure of buildings, there's going to be strong winds, obviously there's going to be rising water, and the great damage again is largely storm surge. And the only thing worse than a Category 4 hurricane, of course, is the Category 5, and at this point you have a storm which is wind speeds in excess of 155 miles an hour. 8 times more power in that wind in a Category 5. And this is precisely the kind of storm which hit Puerto Rico. This storm coming on shore did both the high wind speed damage and the large amounts of precipitation. Very, very deadly storm hitting Puerto Rico. The storm coming on shore, Hurricane Harvey, was not the Category 5. It was the lower category, but it caused its damage because of precipitation. So storm surge, flooding from precipitation, and the high wind speeds all combined, each of them can produce their own level of damage. Well, this is a teach-out, and as a teach-out, we were encouraging you to participate by jumping into the forum and asking your own questions or commenting on things that you've heard. As part of this, we're also going to have videos about the formation of hurricanes, the physics of that. We're going to talk about whether and to what degree climate change might be playing a role in hurricane formation. Is it going to affect their strength or their duration in time or their speed? And also, we're going to talk to experts about who have been in the field, who are in part of the recovery plan, about their experiences and what they're doing. What can we do at the university and beyond when we have an event, a hurricane event like this? How can we participate? What are people able to do in the field? I hope you'll join us again. Thank you.